Lesson 4.2 is about writing equations given a slope and a point. So we've learned how to write equations from a slope and an intercept. If they're in a slope and an intercept, remember that they're in y equals mx plus b form, this form right here. And recall, the reason it's called slope-intercept form is because it has a slope, which is your m, and it has a y-intercept, which is your b. So they're easy to identify. The other form we've learned about is standard form. Standard form is ax plus by equals c, so notice that if we were to draw our line through the middle of the equal sign, x and y are on the same side of the line. The third form we're learning about, what we're talking about today, is point-slope form, which is here in the middle. And the reason that it is called point-slope form is because in this equation we have a point, that's going to be our x1 and our y1, and we also have a slope, which again is our m value here. It doesn't matter which form these are written in, because for linear equations, all forms are equal. Okay, all of these forms, all three of these, slope-intercept, point-slope, and standard form, are all equivalent. They're all the same. They just all look different. So we're going to focus on point-slope form. So point-slope form of a line is in the form y minus y1 equals m times x minus x1. And I know that just looks like a lot of letters, but all those letters mean something. So the letters x1 and y1 represent a point on the line. M represents the slope on the line, and the letters x and y represent all the points on the line. While it seems rather confusing, there's really only a few things you have to pay attention to. So notice that you have an x1. Well, that number, that x value, is going to go in our parentheses on the right-hand side in place of x1. You're also going to have a y value in your point, and that's going to go over here on the left side of the equal sign, and you're going to have your slope, your m, which is going to go in front of the parentheses like it always has. It's very, 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 very important that you notice something. You need to notice that the points changes signs. The point changes signs. It's super duper important that you notice that. So, for example, here, if you look, in the problem it says minus y1, but down here my y1 is positive. So that means if y was positive in the ordered pair, it's negative here. If x was positive in the ordered pair, it's negative over here. So the next line asks us, use the point-slope form when you are given a. Well, it's kind of common sense, because you use point-slope when you're given a point and a slope. Just like we use slope-intercept form when we're given a slope and an intercept. So when we're given a point and a slope, we're going to use point-slope form. If we look at problem 1, we're asked to identify the slope of the line, a point that the line passes through. So remember, we need to pay attention to three things. We pay attention to the number in front of the parentheses, which are -3. We pay attention to the number in the parentheses, which is -2. And we pay attention to the number over here with y, which is +2. And from those three numbers, we can identify our slope and our point. Well, the first thing is our slope, because our slope is always the number that's in front, which in this case is -3. So m in this problem is -3. Because remember, when they ask you for m, all they're asking you for is the slope of the line. That's it. They're asking you for the slope. So the next thing I'm asked to find is I'm asked to find the point. So point, first of all, is going to be an ordered pair with parentheses. And it is always an x value and a y value. Notice I'm color coordinating these very intentionally. Okay? So it's an x and a y. So my job is just to figure out what those numbers are. Well, if I look in the problem, my x value is this -2. So when I write it in ordered pair form, the most important thing to remember is that the sign has to switch, and so it's going to be +2. Same thing is true with my y. My y value that we were given in the point is the +2, so when I write it in ordered pair, it's going to be a -2. So again, I want you just to make a note that the signs here and here, the signs are going to switch. So we look at problem 2. We're going to do the same thing. We have y minus 1/2 equals negative 2 times x plus 1/2. So we have 3 parts to our problem. Again, we have a slope, we have an x value, and we have a y value. One of the hardest things that people tend to get the most confused about is which of these numbers is x and which one is y. Well, here's what I'll tell you. The x value is with x, and the y value is on the same side as y. So we could even go so far, and you don't have to do this, but you could draw your line and label your sides as y and everything else. And what you see is that over here, this negative 1/2 is on the y side, and that's because it actually is a y value. It's our y value in our ordered pair. So when we go to fill everything in, we know we need our slope. Well, our slope was this number in front of the parentheses, which is negative 2. And our point, the x and the y, so here's my x value and my y value. These two numbers are going to come from what's inside with the other two numbers in our problem. So my x value is positive 1/2. So remember, it's going to switch signs. So it's negative 1/2. And my y value is negative 1/2. Again, it's going to switch signs, and it's going to be positive 1/2. So now we're going to go the other direction. We're going to be given a point and a slope, and we're going to have to write the equation. So they've given you 3 steps. So step 1, identify the slope m. So I'm going to highlight that in pink because that's what I'm going to do in pink every time. And we're going to go ahead and do this for problem 3. So it asks you to, the instructions say to write an equation in point-slope form of the line that passes through the point and has the given slope. So the first thing I'm going to do, step 1 up here, remember it said identify the slope, which is m. So in this case, m is negative 2. So I'm going to go ahead and fill that in and recall that your slope is what goes out here in front of the parentheses. So I'm going to put negative 2 out there. Step 2 says to label the point x1 and y1. So I'm going to label my x1 in green, and I'm going to label y1 in yellow. So when I look at this point here, I have the ordered pair 3, negative 1. So I'm looking at this ordered pair, 3, negative 1. Remember that the first number is always x, the second number is always y. So that means in this case that 3 is x, and that's going to go in here, and that negative 1 is y, and that's going to go over here on the left-hand side, and now it's just our job to plug in the numbers. So when we put them in, remember they're going to switch signs. That's super important. So instead of a positive 3 in the parentheses, we're going to have a minus 3, and instead of a negative 1 on the right side, on the left side, we're going to have a positive 1. So our equation would be y plus 1 equals negative 2 times x minus 3. That's the equation of our line. So we're going to do the same thing with problem 4. First thing we're going to do is we're going to identify our slope. So our slope is whatever they've given us, which they told us our slope was negative 2/3. And remember, that's going to go here. So I'm going to go ahead and plug that in. Negative 2/3. The next thing we're going to identify is our x1 and our y1. So that's just our numbers, our 4 and our 0 that we're plugging in. Remember that x goes in the parentheses with x, and the y value goes over on the left-hand side with y. And then we're just going to write our numbers in. So instead of where the yellow is, I'm going to have a plus 0, or you could put minus 0 because technically 0 doesn't have a sign, so putting plus or minus doesn't matter. And if you add 0 or subtract 0, it's the same thing. And on the right-hand side, instead of positive 4, I'm going to put negative 4 because I always, always, always switch my signs. So sometimes they decide to make life complicated. And instead of giving you a point and a slope, they give you 2 points, which sounds really ridiculous and really difficult. However, remember, we know how to find the slope. We can find the slope by using the formula y2 minus y1 divided by x2 minus x1. This is our slope formula. And then once we have that slope, we can use the point slope form. So we can go back up here and we can then follow these steps again, really steps 1 and 2, because we put them all together. So the first thing we got to do for problem 5, they give us 2 points, -4, 6 and -2, 5. So the very first thing we're going to do is find our slope. So step 1, we're going to find our slope. So I'm going to draw my line. I'm going to put my minus sign in there. And my job, if you'll remember from when we've talked about point slope form, is we've just got to fill in these numbers. There's going to be a y here on top and a different y subtracted from it. And then there's going to be an x on bottom and a different x subtracted from that as well. So it doesn't matter which point we put first, so I'm going to color code this one as my light pink, and I'm going to color code this other point, -2, 5, as my purple. Remember that your y's go on top, which means 5 is going to go on top, and -2 is going to go on bottom, and then 6 is going to go on top, and -4 is going to go on bottom. And we can just plug them in the calculator. Well, 5 minus 6 is going to give us -1. -2 minus -4, mathematically, that's the same thing as saying plus a +4, and that's going to work out to give us a +2. So we now know that our slope, in this case, is -1/2. So that's my slope. So we have now successfully completed step 1. We found our slope. So now we need to use point slope form, but in order to do that, I need a point. Well, I didn't get 1 point. I actually have 2 points here, so I just need to pick one. So you've got to remember at this point that you will need to pick a point. And the good thing is it does not matter which point you choose. So it doesn't matter which you choose. So I'm going to look back up here and I'm thinking, you know what, I'm going to use -2, 5 because those numbers are smaller. So there's really no rhyme or reason for why I picked it, but -2 and 5 just sounds a lot better than -4 and 6. So for my slope formula, or for my point slope formula, remember I have a slope, I have an x value, an x1, and I have a y value, a y1 that I've got to substitute numbers in for. So we've already found our slope. We said our slope was our -1/2. We know that x from this ordered pair here, our x value is -2. And then our y value is actually going to be +5. So we're going to rewrite this as y minus 5 equals -1/2 times x plus 2. Again, notice that our signs are going to switch. So recall that in our ordered pair, this 2 was negative, but down here it is positive, and my 5 was positive, but in the equation it is negative. So in a later question on the notes, we're actually going to be asked to write this equation in slope-intercept form. So we're going to write this. It's actually problem 8. On the back says to write in slope-intercept form. If you need to look back at the top, you can, but remember that slope-intercept form means it's written in the form of y equals mx plus b. That's what we need to get this into, is y equals mx plus b form. Well, in order to do that, that means I have to take my equation, y minus 5 equals -1/2 times x plus 2, and I need to solve this equation for y, which means I need y's on one side and everything else on the other. So I've drawn my line. Well, notice over here on the right, I have -1/2 and I have parentheses. That means the very first thing I need to do is I need to distribute. So -1/2 times x is still -1/2 x, negative 1/2 times positive 2 is going to give us a negative 1. So on the left side, I still have y minus 5 equals negative 1/2 x minus 1. So if I need this side to be my y side, that means this minus 5 has got to go. So to get rid of minus 5, I'm going to plus 5 to both sides. I can't plus 5 to negative 1/2 x because it has x, and 5 here doesn't have x. So I'm going to have to add 5 to the negative 1, and that's going to give me the equation y equals negative 1/2 x plus 4. So now I know two things about my line. I know that the slope, my m, is negative 1/2. We found that earlier. But from here, I've also learned that my b, my y-intercept, is positive 4. So I'm going to write that in the ordered pair form of 0, 4. Problem 6 on the back asks us for literally the same thing as problem 5. It's just asking in a different way. So it says write a linear function of f with the values f of 4 equals negative 2 and f of 12 equals 10. It's important to remember that normally we see f of x equals y. So say I'm going to write that underneath both of these, that f of x equals y. So what that is telling us is that in this ordered pair, that x is 4. In this ordered pair, x is 12. And it's also telling us that y is negative 2 for the first one, and y is positive 10 for the second. So I go ahead and fill those in. My ordered pair is 4, negative 2, and my second ordered pair is 12, 10. So now that I have my ordered pairs, the very first thing I've got to do to write this in point slope form is to find the slope. And I'm going to find slope using my slope formula, which is y2 minus y1 divided by x2 minus x1. So all I've got to do is plug in numbers. So I'm going to say y2 is negative 2, so it'll be negative 2 on top, which means 4 has to go underneath that. And then 10 has to go on top, and 12 has to go underneath that, and I always minus. So on the top, negative 2 minus 10 is going to be negative 12. And on the bottom, 4 minus 12 is going to be negative 8. And a negative 12 divided by a negative 8, you can put this in your calculator if you need to, is going to reduce to a positive 3 over 2. So I now know that for this problem, m equals 3 over 2. Remember, my second step is to use point slope form, and that's y minus y1 equals m times x minus x1. So I've already figured out what m is. I know m is 3 over 2. And then to figure out x1 and y1, we're going to need to pick a point. So we have 2 points up there that we can choose from. It doesn't matter which one. So I'm going to go with 12 and 10 because they are both positive. That's literally the only reason I'm picking this. So in 12, 10, my x value is 12 and my y value is 10. So that tells me what I'm going to be plugging in. So I'm going to rewrite this. Instead of y1, I'm going to put minus 10 because remember we always are going to change our sign. Equals, instead of m, I know that m is 3 over 2. And then x, and instead of x1, I'm going to put minus 12. Because again, I'm going to change my sign. So remember, up here 12 was positive, down here 12 is negative. Up here 10 was positive, down here 10 is negative. From a graph, we can do the same thing like we have here on problem 7, but the great thing is we can find our slope easily because remember that our slope in a graph is our rise over our run. So I need to figure out how to get from this point, negative 1, or 1, negative 2, to this point, 3, 2. And you could use point slope formula if you wanted to, but you could also just rise and run and count your steps. So if we're going to do that, then starting here I have to go up 1, 2, 3, 4, and I go over 1, 2. Both my directions up and right were positive, so my slope is going to be 4 over 2, and 4 divided by 2 is 2. So right now, what I know is that m equals 2. So now I need a point to write this in point slope form. So recall they gave me 2 points, -2, and +3, 2. It doesn't matter which one we pick. I'm going to personally prefer anything that's always positive. They have the same sign, it makes life a lot easier. So I'm going to pick the ordered pair 3, 2, but I could have picked the other one. It would not matter. I would end up with the same answer in the end. So I'm going to use the ordered pair 3, 2, and now I need to write this in point slope form. So you see point slope form here. So recall that we need a couple things. We need our slope, which we have. It's our 2. We need an x value, which we have. It is +3. And we need a y value, which we also have, and it is +2. So we're going to rewrite this equation. Remember, we always switch our signs. So instead of being a +2 here, we're going to write that it's a -2 equals. My slope stays the same, so it's +2, and then x. And instead of +3, we're going to write a -3. So there's my equation. Y minus 2 equals 2 times x minus 3. So we've already done problem 8. We did that on the front side. We solved for y. So just remember, if it wants it in slope-intercept form, all that means is it wants it in y equals mx plus b form. So question 9 says, what conclusion can be drawn about the point-slope equation and the slope-intercept equation for 5? Well, we said this on the front page that they are equivalent. That means they represent the exact same line. So looking at number 10. The student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. The first question asks, can the situation be labeled by a linear equation? To tell if it's linear, we've got to figure out how much it's going up by every time and see if there's some consistencies there. So from 34 to 46, that is an increase of 12. From 46 to 58 is an increase of 12. From 58 to 70 is an increase of 12. And from 70 to 82 is also an increase of 12. And we've got to do the exact same thing for the x's up here. So when I start working with my x's, well, from 4 to 6 is going up by 2. From 6 to 8 is going up by 2. From 8 to 10 is going up by 2. And from 10 to 12 is also going up by 2. So notice every time these numbers were the same and these numbers were the same, so that was a good thing for us. But really and truly what matters is not that those numbers are the same. That helps us because it makes life easy, but what matters is that when you divide this change in y down here at the bottom by the change in x, you should always get the same thing. So if I do 12 divided by 2, I'm going to get 6, and it's not going to matter if I pick this 12 divided by 2, or this 12 divided by 2, or this 12 divided by 2, or this 12 divided by 2, I'm always going to get 6. The other reason that's really good for us is because now we have actually found our slope. Our slope of this line is +6. So the actual reason that this situation can be modeled by a linear equation is because there was a constant rate of increase, which we found out was 6. So part B says to write a linear model that represents the cost as a function of the number of foam hands. So what that means is I need to write this in point slope form to start off with. Y minus y1 equals m times x minus x1. So recall, we already found our slope. We said our slope was 6. So now we just need a point. Just glancing back at our table, notice we have a lot of different points here. So we just need to pick one of them, and it doesn't actually matter which one we pick. So because I'll notice that these numbers are getting pretty big, I'm going to pick this one, 434, because I don't really want to have to write and work with really big numbers. So I filled in my point, and now I just have to go up here into my point slope formula, y minus y1 equals m times x minus x1, and fill in my numbers. So remember, my slope is m, which we said was 6. My my x value was 4, and my y value is 34. So we're going to rewrite this. Remember, my signs changed, so instead of +34, it'll be -34, equals 6 times x, and instead of +4, it will also be -4. I do need to solve this for y, which means I need to get y's on one side and everything else on the other. So on the left-hand side, on the right-hand side, I do need to distribute. So 6 times x is 6x, and 6 times negative 4 is negative 24. So I have y minus 34 equals 6x minus 24. And then to get rid of that minus 34, I'm going to add 34 to both sides. So I end up with y equals 6x plus 10. And this would be my final answer because this is the equation of my line in slope-intercept form. So last problem, Carlos is driving at a constant speed of 60 miles per hour. Right now, this word per should have jumped out to you because we've talked about time and time again that when we see the word per, what they are telling us is that this number is a slope. And more specifically, that it's our y's per our x's. So we know right off the bat without doing any work that our slope is 60. Then it says after driving 3 hours, his odometer reads 265. So notice if this is my y's, which is my miles, per my x's, which is my hours, then I already know that my hours is 3, my x's are 3, and my miles is 265, which means my y is 265. So the question asks, what have they given us? Have they given us a slope and a y-intercept or a point and a slope? And if they had, remember, if they've given us a y-intercept, they would have had to give us something that was an initial value. So a y-intercept is an initial value, which they didn't give us. So we have a point and a slope. So we're going to write our equation. So first we're going to write out what our point and our slope are. Well, our slope is 60, and our point is the ordered pair 3, 265. So to write the equation, we have a point and a slope, so we're going to use point slope form, y minus y1 equals m times x minus x1. We already know what our slope is. We also know what our x value is, and we know what our y value is. So all we have to do is rewrite this. So instead of y minus y1, I'm going to have y minus 265 because that was my y, equals, instead of m, I'm going to have 60, and instead of x1, I'm going to have x minus 3. So I've rewritten this because they have asked us to write it in slope-intercept form. So remember, if it's slope-intercept form, that means that we need to write it in y equals mx plus b form. So we've got to solve this for y. So to do that, we need y's on one side, everything else on the other. So on the right-hand side, I'm going to distribute 60 times x is 60x, and 60 times negative 3 is negative 180. So I have y minus 265 equals 60x minus 180. To get y by itself, I'm going to add 265 to both sides. I'm adding it to the 180 because notice this has an x, neither of these does, so these are like terms. So we end up with y equals 60x plus 85. Where my slope is 60 and my y-intercept is 85. So our last question says, what does the odometer read after 7 hours of continuous driving? So if we go back and look up here, notice that it was our miles per hour, which was our y's per our x's. So that tells us that our hours are our x's. So if they've given me 7 hours, they have given me an x value. So that means all I have to do is take out x, and instead I'm going to put in 7, because in this case they're giving me that x value of 7. So I'm going to rewrite the equation. So y equals 60, instead of x I'm going to put in 7 plus 85. Well, that's going to be y equals 60 times 7 is 420 plus 85. And 420 plus 85 is 505, and that is y's. And remember, our y's was our miles, so it's going to be 505 miles.